I said differential equations, basic definition. I said a differential equation by definition is simply an equation which contains at least one differential coefficient of an unknown function which gives a relationship between the dependent and independent variable. In a course of studying differential equation, we have things like homogeneous equation, first order, second order, exact, linear, non-linear. What do these things mean? Let's take them one after the other, please. Please, first things first, please. Order of a differential equation. Let's start with that. Order of a, let me call this DE, please. DE for differential equation. Order of a differential equation. Alright, take down please. This is equal to order of a differential equation. This is equal to the highest differential coefficient. This is equal to the highest differential coefficient involved in a differential equation. It's equal to the highest differential coefficient involved in a differential equation. Alright, so I said order of a DE is equal to the highest differential coefficient involved in a differential equation. Let me explain what differential coefficients mean. Please look up, please. Now, we know very well that let's start with basic differentiation. If I have that y is equal to, let's say, x to the power 4, for instance. Now, if I differentiate the first time, if I differentiate y with respect to x, I will get dy dx as equal to, what do I get? 4x power there, 3. Differentiate this answer here. If I differentiate dy dx, what do I get there? The square y, all over there, in x squared. And that's equal to, what do I get? 12 x power there, 2. I have this. Let's do this one more time. Let me differentiate this again. What do you have there? The cube y all over there, the x cube is equal to 2 times 12, 24, x into 2 minus 1, 1, 24x. So look at this please. When we say differential coefficient, what we mean is simply the y dx, the square y over the x squared, and then the cube y over the x cube. These are the differential equation, the differential coefficient. So in essence, if I'm given a differential equation where the highest differential is, or where the highest differential coefficient is dy over dx, it is called a first order differential equation. Just that simple. If I'm given a differential equation where I'm having the square y, because this is now 2, it becomes the order. So it becomes a second order differential equation. If I'm given an equation in this form where I'm having 3, then it becomes what there? A third order differential equation. So if I give you something like this, I just say something like this. Let's say 2 dy dx is equal to 4y plus 3x, for instance. What I have here is a first order differential equation. Of course, the highest here is just 1. If I give you something that looks like 4 the square y all over the x squared minus 2 dy dx plus 7 is equal to 3y, for instance. What I have here is a second order differential equation because the highest differential, please, right? You could have more than one differential coefficient, yes, but the highest is what there? 2. So it becomes what there? A second order differential equation. For this course, you'll be treating just first order and second order. I think if you finish your engineering maths, then those guys that are maths guys, I don't know, you might now do third order. But this stuff will be very crazy. So that's it basically. So when we say order of a differential equation, you know what it means now. Let's look at the next thing again there. So the first thing we look at is order of a differential equation. Number 2, please. Let's look at degree of a differential equation. Degree. Let's look at degree degree of a differential equation. Alright. Degree of a differential equation. This is equal to, so under this, think about this. This is equal to the degree in bracket par or index. Degree of a differential equation. This is equal to the degree in bracket par or in power or index, close the bracket. This is equal to the degree in bracket par or index to which the highest differential equation, to which the highest differential coefficient is raised. This is equal to the degree in bracket par or index, close the bracket, to which the highest differential coefficient is raised. Full stop. To which the highest differential coefficient is raised. Full stop. Example. Given the following differential equations, state their order and degree. Example. Given the following differential equations, think about it. Example. Given the following differential equations, state their order and degree. Given the following differential equations, state their order and degree. Alright. So let's deal with these ones. So for each of these we get the order, we get the degree, and we can proceed. Of course. So for each of these, let's get the order, let's get the degree, then we can proceed. Right, if we're good, let's get started. If you're good, let's get started. Alright, so for this, I'll do 1, 2, 3, and then you try 4. Alright? What's the order of a differential equation? Simply the highest differential coefficient in that equation. Full stop. What's the degree? Simply the par to which the highest differential equation is raised. That's all. Now let's start with this one here. From here, let's start with the order for this one here. Alright? Looking at this, we can see that the highest differential coefficient is the x in t. That's what there, a first order. For this one here, the order is equal to 1. The first order differential equation. What's the degree? For this one here, degree is equal to this one here. Is raised to what part here? 1. So order 1, degree 1. So this equation here is a first order, first degree differential equation. That's all. Next up, this man here. Let's get order, let's get degree. For the order here, I'm looking for the highest differential coefficient. Please look at this, please. What's your highest differential coefficient? Of course, this one here. d squared x over dt squared. So it's of order 2. Again, for the degree, look at this carefully. What's the degree of this differential equation? 1 or 4? Look at this one here now. What's the degree? 1 or 4? When you're looking at the degree, we said it's what there? The power. The power of what? To which the highest differential coefficient is raised. For this question here, what's your highest differential coefficient? This one here. This is not the highest, it's the highest here. This one here is raised what power? Power 1. That's it. Please just hang on, just hang on, hold up, get it. Please, we're looking at the highest differential coefficient, please. The third one, look at this one, please. First things first, what's the order here? Looking at this, the highest differential coefficient is the square y all over the x squared. So it becomes what there? A second order differential equation. So the order here is equal to 2. What's the degree? If I look at this man here, this man is still raised to power 2. So 2 is the power to which the highest differential coefficient is raised. So it becomes 2. Please, for you, fill out this part, please. For you, please, fill out this part, please. Let's proceed, please. Fill out the last one. Let's proceed, please. Fill out the last one. Let's proceed. Put the order, put the degree. Let's proceed. Put the order, put the degree. Let's proceed. For order, what do you have? 3. Obviously, it's a third order. 3. Yeah. For degree, what do you have? 1. Of course, it's raised to power 1. I have this. Alright, your task is. Your task is. Get me the. There's no space. Let's assume this one line equation. There's no space, please. For this question, please, what's the order? What's the degree, please? What's the order? 3. Order what? 3. Order 3? Degree what? 4. What's the order here?
Order 2. Order 3. Order is 3.
Huh? Use your eyes. Shall we shall this thing yesterday? For this one here, this is straight line equation. What's the order? What's the degree? Order what? Order 2. Degree what? Please say your own mind. Don't follow everybody. Say your own mind. Order 2, degree 3. If you're against this, say your own. Yes. No, feel free now. Feel free. No big deal. Order what? Order 1. Order 1 degree what? Order 1 degree what? Yes. Order 1 degree what? Order 1 degree 1. Okay? Who else? I don't know which of them. I don't look at the group. Which one? You're not ADC. The green partner is ADC. No, that PDP. So PDP is there. Okay. You're not in any of that. Okay, I'm not sure, is it? I'm not sure. The first thing you should have noticed is that the question was even wrong. The question was wrong. The question was wrong. Right? See what I did. Listen. See my different. That's what you have to. Just like using that book, they're using this book and this book. There are a lot of errors in that book. Yes. So if you check my book, you see I corrected it. So you have to understand so that you don't make that mistake. Because sometimes you're studying these things, and if you don't know how this works, you'll be seeing error. You yourself you're correct, but you think you're wrong. You know what I'm saying? In that text that I'm holding, there are a lot of errors. I've gone through, there's so many errors inside there. So you have to be sure of what you're doing. So listen, there is no way you can have, when I have the squared y, what follows up is what there? The x squared. Whenever you have the cube y, what follows up is what there? It doesn't make sense to have 3 here and 2 here. Come on, this is wrong. It's a wrong equation. That's the answer. So there's no other. This is a wrong equation. This is wrong. So please open your eyes, please. Let's proceed, please. Next up. Homogeneity of a differential equation. So you hear that a differential equation is homogeneous. What does it mean? Homogeneity of a differential equation. Please take that with. A differential equation is said to be homogeneous. Take that with. A differential equation is said to be homogeneous if it is equated to 0. Now, this concept is actually a basic idea anyways. There are more to it. But for now, let's take this as a basic idea. As I said, there are more to it. For now, let's take it as a baseline idea. A differential equation is said to be homogeneous if it is equated to 0. And non-homogeneous if not equated to 0. And non-homogeneous if not equated to 0. Full stop. We'll end with this. Linear and non-linear. Linear and non-linear differential equation. Linear and non-linear differential equation. A differential equation is linear. A differential equation is linear. A differential equation is linear if the highest differential equation, please, if the highest differential coefficient, a differential equation is linear if the highest differential coefficient is raised to power 1. If the highest differential coefficient is raised to power 1. Else it is non-linear. Else it is non-linear. Else it is non-linear. Alright, what I have here, look at this. We mentioned how many things so far. We mentioned the order, we mentioned what's again there, degree, we mentioned what again there, homogeneous, we mentioned what again there. This man here is a second order, first degree, homogeneous linear differential equation. True or false?
True.
Please listen again. Listen again. What I have here, let me write it down. It's a second order, first degree, homogeneous linear differential equation. True or false?
True.
First things first, second order, it's second order. Okay? First degree, this man equals to power 1. Yes, it's first degree. Homogeneous, of course, equated to 0. And I said this concept here is a basic idea, although it can be much more, there are much more conditions. But let's say equate to 0 as homogeneous, and then it's linear. Why is it linear? Because the degree, now here's the concept. It is the degree that determines if it's linear or non-linear. If the degree is 1, it becomes what there? A linear differential equation. If it is not 1, perhaps it's 2 or it's 3, it becomes what there? Non-linear. Alright, I think we've done enough with the introduction. Let's now go into how to solve questions. I know your work probably did how to derive, how to form differential equation. But that will take us another time there. So we'll look at that one much more later. Let's look at solution. Let's look at solution. Well, please, before we look at that one then, let me give you this task. You have this. Please write out the name of this type of differential equation in terms of order, degree, homogeneity, and linear, non-linear. If the equation is not correct, please write it's not correct. So open your eyes while you're doing this. Alright. So please, on your own, please write out the order, write out the degree, write out if it's homogeneous or non-homogeneous, then tell us if it's linear or non-linear. You have just 120 seconds. Your time starts now. You have just 120 seconds. Your time starts now. Hope you're done with it. What's the order? What's degree? Sorry? Second degree. 2. Second degree. What's the homogeneity? Non-homogeneous. Okay. You can't say it's non-homogeneous anyways. Chief, come with me. What's the linear or non-linear? Yeah, Chief.
What if it's not correct?
No, I asked a question and you asked me back again. So you have to.
I agree, my answer is not correct.
And if the truth is that this question is not even correct. Open your eyes now. Come on. Open your eyes now. Come on. The question is not correct. Okay, just hold on there. Now, can you think of what's wrong here? No, hold on. Think of what's wrong here, please. Look at the question very well, please. What's wrong? Yes. See. That's it. That's it. I can't be having. Check your previous examples. If I'm using the y and t, it's always the squared y, the t squared, the y, the t. How are you having the cube y, the t cube, and not having the y, the x? How? It's not true. So it's wrong. It's wrong. If you're using the y, the x, it should be the y, the x throughout. Now it's correct. If you're using the y, the t, you're using the y, the t throughout. So it was wrong. Now, check. Is that the only error here? Check very well. Open your eyes. Can you spot another error here? Huh? Check now. There's one last thing here. Can you spot another error here? No, I can see A1. No problem. That's not really an error. This is correct. Correct. What would have been wrong? What would have been wrong is if I had done this x and x. What would this have been wrong? Because the function is t. Open your eyes. Open your eyes. Understand this thing. Alright, with this now, we know that this is what there. Third order, second degree. It says non-homogeneous. Okay, non-homogeneous. What if they had said m of t is equal to 0? For now, let's assume m of t is not 0. Right? So it becomes a third order, second degree, non-homogeneous, non-linear differential equation. Alright, that's about it. Let's look at how we can solve them. Solution to, or solution of a differential equation. Right, solution of a differential equation. First things first, the first method we have there is direct integration. Yes, probably 6:30. Or when you just go, when you go, just one. Alright, first thing there, direct integration. That's the first method. First method. The second one is called the variable separable. So I call it variable separable method or separation of variables method, any of them. Right? Variable separable, separation of variables method. The third method is not actually called the method, but anyways, the third method involves substituting. This is not a method, it's just the step of solving. Substituting y as equal to vx. This is the third method there. It's not a method, it's how we call it. But then, just note that in a third method or a third process, you have to use y as equal to vx. Then finally, a fourth method, not finally anyways, is use of integrating factor. Integrating factor. That's IN. Use of integrating factor, that's this. Basically, these are like the four methods. Then there's one thing they like chipping in, right? It's not a method, but it's still first order differential equation. That's called something called exact equations. Exact equations. Alright. So basically, if you know this stuff here, you can solve differential equation no matter how you twist the questions. If you can master these 5 methods, you can solve for now. Then those of you doing maths, and when you now do differential equation in maths 306, you now see other sub methods under this, right? For your own exam, most likely they'll give you a particular differential equation. They'll ask you to check if it's exact. Most likely it will always be exact because they want to solve it. But there's a higher form where it will not be exact. And when it's not exact, you now use something called an integrating factor to change a non-exact to an exact. The integrating factor has 4 different cases. case 1, case 2, case 3, case 4. That one is common, and that's the one you now do in Maths 306. Right? So, but for now, you know this one here, you're good to go. So let's go through all of these methods. So I have about 12 of you, how many on each of them. So just solve as many as possible. Once you can master this, first order is gone. We look at application, second order, application, the exam is good to go. Right? Let's start with the first one there. I want to play this. Hope you're done. Let's start, please. Let me get the questions. Alright, let's start with the first one then. Direct integration method. Alright, what are these? Take down, please.
Get more by joining our Differential Equations channel membership or visit www.joniemanual.com/courses and get the Differential Equations Made Easy course. Both links in video description.